In question 2 we have an equation. Let's solve it. Question 2 we have 4 divided by x plus 3 plus 3x divided by x minus 4 and then minus x minus 1 divided by x squared minus x minus 12. That's equal to 0. Okay, what can we see here? We see that we have different denominators and we would like to make them equal. Well, let's do that. Let's make the first two terms with the same denominator. Let's multiply this thing by x minus 4 and let's multiply this thing by x plus 3. So we would have 4 times x minus 4 divided by x plus 3 times x minus 4 plus 3x times x plus 3 over x plus 3 times x minus 4 and then minus, and here we have x minus 1 divided by x squared minus x minus 12 equals to 0. Now, in the first two terms we have the same denominator, but let's see what happens in the last term. What is x squared minus x minus 12? Let's solve it over here. X squared minus x minus 12. Well, if we solve x squared minus x minus 12, how can we do it? Let's use our shortcut. Let's apply that shortcut where we take x, and we must have two numbers that when we multiply we get minus 12, and when we add them with the term of x we get minus x, we get the middle term. Let's try 3 and minus 4. 3 times minus 4 equals to minus 12, so that works. And if we add 3x minus 4x, the result will be equal to minus 1x. And minus 1x is the middle term over here, so that works as well. Which means that as a result, our x squared minus x minus 12 can be written as x plus 3 times x minus 4. So let's do that over here. X plus 3 times x minus 4. If we write everything again, we would have 4 times x minus 4 plus 3x times x plus 3 minus, and now we can take x minus 1 also with these terms, because remember, x squared minus x minus 12 is equal just to x plus 3 times x minus 4, so we have the same denominator for all three terms. So we're dividing by the same denominator now. X plus 3 times x minus 4 equals to 0. Okay, one thing we have to keep in mind is that division by 0 is undefined, so x plus 3 cannot equal to 0, and also x minus 4 cannot equal to 0, which means that x cannot equal to minus 3. So from here we know that x cannot equal to minus 3 and x cannot equal to 4. This is our domain. We must keep this in mind. Okay, so how can we solve this right now? Well, we have 4 times x minus 4. Let's open the brackets. 4 times x is just 4x. 4 times minus 4 is minus 16. Plus 3x times x is 3x squared. 3x times 3 is 9x. And then minus x, but then minus 1 changes the sign into a positive. So we have plus 1 divided by x plus 3 times x minus 4 equals to 0. Okay, let's make it a bit more neat. We have 4x plus 9x. That equals to 4x plus 9x minus x. That's equal to 12x. We have 3x squared, just 3x squared, no other x squared there. 3x squared plus 12x, and minus 16 plus 1 is minus 15, divided by x plus 3 times x minus 4 times x minus 4 equals to 0. Now, when can a division equal to 0? Only when the numerator is equal to 0, because remember, the denominator cannot be 0 because it's undefined. So 3x squared plus 12x minus 15 equals to 0. What can we do to make it a bit more neat over here? Well, we can divide both sides by 3. We could do both sides divided by 3 because it's an equation and we can do that. So we would have x squared plus 4x minus 5 equals to 0. Now how can we solve this by using our shortcut? Well, we have x and x, and then here we must have a term that when we multiply we get minus 5, and when we add we get 4x. So if we do 5 and minus 1, 5 times minus 1 equals to minus 5. And if we take it with the x term, we would get 5x and minus x equals to 4x, and that's exactly the middle term. So this should work out, which means that we would have as a result x plus 5 times x minus 1 equals to 0. So either x plus 5 is 0 or x minus 1 is 0, which means that the result that we're getting is that x is either minus 5 or x equals to 1. X equals to minus 5 or x equals to 1. Now let's go back to our domain to see if this does not clash with our domain, if this is actually possible. Well, the domain says we cannot have minus 3 and 4, but our result is minus 5 or 1, so they are both satisfying with our domain, which means we can use them as our final answers. And that's it, we are done.